Blacks in Technology.
Blacks in technology. Blacks in technology. Blacks in technology. Blacks in technology. Blacks in technology.
Welcome, everybody, to the 29th episode of the Blacks in Technology audio podcast. I'm your host for this evening, Greg-greenlee, along with co-host Ronnie Hash. Today it's, March 23rd, 2012. If you never visited the site before, you can check us out at www.blackandtechnology.net. You can also follow us on Twitter at blackandtechnology. That's BLKTECHNOLOGY. We also have a LinkedIn group under the name Blacks in Technology and a Facebook group under Blacks in Technology. Tonight, what are we going to get into? Let's first start off with member count. We're up to 540 members on the site. Big thing.
Yeah, thanks for the deal, man.
So, keep the membership, growing, keep the community growing, spread the word, because we are definitely growing every day, it seems. So that's very good news. Also, I recently attended South by Southwest for the first time in Austin, Texas. Pretty fun time. I actually stayed with a member of the Blacks in Technology site while I was down there, Lavelle Watson. He actually offered to put me up for the week. So shout out to Lavelle. We had a pretty good time. South by Southwest. My thoughts on it, tiresome. Just a lot to take in, a lot to digest, and it's just so massive. It's pretty much, covers downtown, and it's so there's so many people down there that you can't. It's hard finding good places to park. And then when you park, you're walking about 6 or 8 blocks just to get to the convention center where some of the main stuff is, and then you're walking around all the convention center all day, and then you walk around and get to places to eat. So overall, it was a great experience. The best part about it is that met a lot of people that I only know online or have met online. Some people that have actually been on the Blacks in Technology podcast before. I met a few of them. People that I met, through, some affiliation with Blacks in Technology, whether they've been on it or whether they know somebody that's been on it. People from Twitter. So it was just great to meet a lot of people face to face. I handed out a few Blacks in Technology T-shirts. So that was pretty good. And then, just meeting up with Ravel, who's very intelligent, very smart guy, just talking tech with him pretty much the whole entire week. It was a good experience. And what else about? Went to a few of the talks. I didn't actually have an interactive pass. Scott Hanselman, he was on one of the panels for, I think the panel was called Race, No One to Hold It, No One to Fold It. He actually hooked me up with a day pass, so shout out to Scott for that. Thanks a lot. So I was able to attend a couple of days of panel talks. Hadia and Anwan Simmons and those guys hooked me up with another day pass, and I actually videotaped their talk for, it was, not Anwan, I'm sorry. It was Hadia, Nina, Chris Bennett, and Monique Woodard. They're all from Black Founders, and they had a talk on startups. So shout out to them for hooking me up with a day pass as well. Black Founders is actually going to be having a conference in New York City. Let me see if I can find out when that is. It's in April, I know, but when is the conference? Here it is. I'm looking this up right as we speak. April 11, 2012, and they have some pretty good speakers. Hank Williams of Cloud Code, he was on Numi Accelerator. I think I'm pronouncing this right, Asmau Ahmad. She's an engineer and founder of Plum Perfect. Freight Denbo, sounds like, developer and entrepreneur. Song Sickle. David Rose is a serial entrepreneur and angel investor. So they have a pretty good. Bob Dorff, keynote speaker. He's a co-author of the Startups Owner's Manual. He'll be the keynote speaker. And the premise of their conference is ideas are worthless. And it's pretty much centers around the mindset that, talk is cheap. If you're going to have an idea, your idea is cool, but are you going to actually put things into play, make things happen? So, looks like a pretty good conference. I'm actually going to be hitting up Hadia, try to pick her brain on how to develop a conference, because eventually I want to develop one for Blacks in Technology sometime in the future. So, yes, it looks like a pretty good. I wish I was able to attend. But maybe next.
I'll say that week I'm going to be actually in San Francisco. I would have loved to go to New York and check out that conference. When you sent me the link, I looked at the lineup. It looks like a pretty good lineup of different discussions and talks, and like you said, a good group of people that runs Black Founders as well. Yeah,
they've got a few more speakers as well. So it looks like a pretty good lineup. It goes from 1 p.m. to 7 p.m. And it looks like they plan on doing one in some nearby cities. I think Atlanta might be one that's going to go on. So they have a link on the site, and it's blackfoundersconference.com to where you can request your city, I guess, if you want this lineup or you want this type of conference to come to your city. I think that would be, it might be a good idea to try to merge a conference with Black Founders. Black Founders / Blacks in Technology or something like that. I might have to talk to her about that, see if she might be keen on that idea. It might be something worth looking into. But speaking of you being in San Francisco, congratulations to Ronnie. He landed a job out in the Bay. I don't know. Can you talk about that? Are you allowed talking about it, or is it some hush stuff with your job? Okay.
Actually, I landed a. Go ahead.
No, tell us about it. Let's hear all about the company. Hear about your position.
It's a pretty good big company. They're called Ubisoft. If you're a gamer, you know who they are. They make Just Dance 3, Far Cry, Assassin's Creed.
Nice.
So they make a lot of big name video games. So what I'm going to be doing is working on their online social network gaming team. So a lot of my work is dealing in the cloud, working with the developers on getting their applications deployed in the cloud. I'm currently working on automating their cloud infrastructure setups and putting best practices around that. So I'm doing a lot of pretty exciting things in the cloud and working with the developers and stuff like that. So
nice.
A lot of new games is coming out on Facebook. I hope everybody hop on. As soon as we release them, I'll let people know about it. Of course, I can't talk about them until they release, but I get to play them while I deploy. Yeah, it's pretty cool. Me and a coworker, deployed an app in our staging environment today, and I got to play it for a little bit to test it out. So pretty cool.
So, which is pretty much going into our topic for this evening, which is cloud computing. And we're just going to, pretty much talk about, what our experience is with cloud computing, what cloud computing is. There's a lot of talk out there about on the internet about what it is, and to me, some people are getting it wrong, period. I I wouldn't even say getting it wrong. That might be a little bit harsh. I would say not explaining it correctly as to what it is. And some people, and a lot of times, you get mired in, everything is a cloud, or this is a cloud, or that's a cloud, and some stuff gets kind of lost in translation as to what it really is. And there's some people really don't know what it takes to actually have a cloud or have that, that computing environment. They don't really know what the cloud is. All they know is that their data is somewhere in the cloud. So we're pretty much going to talk about that, talk about some of the infrastructure that goes behind building the cloud, as well as, Ronnie will elaborate more on, the tools behind deploying applications in the cloud and just, working with the cloud, period. So I want to first talk about a book that I began reading. I haven't gotten through the whole thing, but it's called The Cloud at Your Service. And the reason why I'm bringing up the book is it's a real good book about what cloud computing is and understanding it. But there, in the beginning of the book, it starts talking about 5 main principles that define cloud computing, because there's a lot of people thinking cloud computing is just a buzzword, that it's been here for decades or years or whatever. And I honestly don't think it has in that aspect. If you look at these 5 main principles, and I'll go over the principles here in a second, I don't think that the cloud has been around in this, form for as many years as people say it has. What do you think? Let me go over 5 main principles real quick. 5 main principles that govern or pretty much say what cloud computing is that it has to have pooled resources, meaning it's available to any subscribing users. There has to be virtualization, of course, which is a high utilization of hardware assets. Elasticity is the biggest key to me. It has to scale, on demand, dynamically, without, any capital expenditures. Automation. Have to be able to build, deploy, configure, provision, and move, all without manual intervention. And metered billing, which is another huge key, another huge factor. It's per usage, just like utilities. It's utility computing, just like your utilities that you pay for every day at your house or something like that, for gas and electric, for water. You get billed per how much you use. And that's a huge key, too. So when people talk about cloud computing that's been around, under those 5 primary principles, I can't agree that it's been around that long, because I don't remember a time where there has been metered billing, where there has been elasticity, or this type of automation that automatically builds out and provisions and configures. What do you think? Am I wrong about this, or?
No, I don't think you're wrong about it. And let's clarify one thing. We're talking about the business cloud aspect of things right now. So we're going to say that there's the user cloud and there's the business cloud. So on the business cloud sense of things, I think a lot of people have said, well, the cloud has always been around. And the reason why they say that is because they go back to the visual diagrams that people see. And on that visual diagram, there's always been a cloud. And they hosted this communication that's happening outside of their infrastructure, which was the network, the internet. They always use that as the cloud. So they like to say, well, there's always been a cloud. But to your point, the many different features behind the cloud computing is the meter billing, the dynamic being able to scale up and scale down, which to a point is still troublesome with a lot of cloud providers right now, depending on the complexity of your application and monitoring. And we can go into that a little bit later.
Yeah.
But to me, I feel that cloud computing is the new way of colo space. Like we always had colo companies where you can store your physical infrastructure in a different data center. And most people opted out to have their own data center and built their infrastructure there. now since virtualization is becoming so popular and a lot of colos are taking advantage of, okay, you don't want to store your physical infrastructure with us, let us invest in a virtual infrastructure, and we're going to sell you VMs now, right?
Yeah.
Because if you think about colo, always had meter billing, bandwidth, all the same things that most cloud providers charge you, but from a different infrastructure.
Yeah.
So to me,
with the exception of actual, CPU and storage and memory usage, that bandwidth has always been metered, power consumption has been metered, but those other three things primarily has not been metered. But yeah, you're right.
So it's a new colo space, really, to me. It's a newer version of how we do colo nowadays. And to me, it makes sense to do it this way because of the economics of it. When you get down into it and when you've been in large enterprises and been part of many projects that have failed and you invested a lot of money in your own physical infrastructure, even if you have your own private cloud or VMware infrastructure, when a new product comes to light and you invest money to expand your virtualization infrastructure, and that product doesn't do as well as you thought it was going to do. Now you have all this hardware left over. So what the cloud is allowing people to do is test concepts. If we have a new idea, let's put it out in the cloud. Let's see how it's accepted to our consumers, right? Let's see if it's really going to do as well as we thought it was going to do. Then the money is well spent. If it shows that it's successful and we can prove that it's worth bringing in-house now, our in-house hosting our private cloud, if it's cheaper that way, let's go ahead and do it that way. But at first, when we doing development, QA testing and all that, let's start off in the cloud. Even our initial launch, let's start off in the cloud.
Yeah.
Then once we start getting heavy usage and all that, then we can run some numbers and see if it's worth investing in our own equipment in-house to expand and then pulling that application into our own network. So I think that's the beauty of the cloud, and a lot of companies are trying to still wrap their head around it and trying to figure out what do we start off and put in the cloud. That's the first thing. Do we currently have anything we can put in the cloud? My thing is anything that you're newly developing, put in the cloud. Some of the drawbacks right now is a lot of companies are trying to say, well, how is security in the cloud?
Yeah.
That's a big factor.
Yeah. Well, there's a couple things. There's a lot of regulations around information, where it's stored physically, who could possibly have access, a lot of HIPAA regulations, Sarbanes-Oxley regulations that prohibit, the use of the cloud in today's current form. Public cloud, that is. And so for those people, you just simply don't use it, or you house, a cloud infrastructure inside your own data center. But people, go ahead.
I was going to say that, or know your cloud provider. Of course, if you go with like Amazon Cloud Services, it's hard to probably get a hold of their security team and understand all their regulations and stuff because they're offering this to a mass market. But to smaller cloud providers, you have a better chance at aligning your business model with their business model, where you say, hey, this is our expectations with our security. Do you guys match us?
Yeah. And there's even and we're going to talk about the infrastructure pieces, the actual equipment, so to speak, that goes behind actually building the cloud. But there's ways to dedicate physical infrastructure to or even segment it in a way that it, to kind of align yourself with the security practices or the security restrictions, so to speak, with these smaller companies, even within storage. So we'll talk about that in a second. But yeah, my main thing with security is this. People talk about security in the cloud, security this, security that, and then they like to bring up the main three, the primary, security essentials, confidentiality, integrity, and availability. Right?
Yeah.
So with that, my whole thing is this. When companies offer public cloud services, they pretty much are companies that have been in the business of data centers, web hosting, email hosting, offering co-location services, things like that, for quite a long time. I'm pretty sure that most of their practices are far better, far more superior than what a lot of these small business practices are, especially when it comes to security, right? Their infrastructure, I would say, are probably, better maintained as far as firewalls, as far as maybe IDSs and IPSs, as far as and when it comes to availability, having multiple circuits coming into that data center in order to have redundancy for any type of outage that they might experience on from one provider. When people talk about housing stuff inside and thinking that having their environment is more secure, what about availability? What about if their internet provider goes down? Most small businesses only have one pipe into their building, right? The other part of that is some of these service providers who offer the cloud have a dedicated security team, or have guys who are very knowledgeable when it comes to security, even if they are not just dedicated security guys, but these guys know security. And some of these smaller businesses probably cannot say the same thing. So when people say, how secure is it, when it comes to the organization for organization, I'm pretty sure that these organizations who offer the cloud stack up a lot better when it comes to security against people that are already within that organization.
Yeah, and I say at least for the first two, the confidentiality and then integrity and stuff, that your guys, if you went with a public cloud, you can definitely easily cover the two, because you have a lot more control over that, on how you implement your servers in the cloud and how you lock them down and secure it. Now, the only piece of it, availability, is going to be your cloud provider. They have to make sure that, like you said, have redundant internet, redundant power, stuff like that.
Also, if you think about it too, that availability falls into the lap of the customer as well, because even with the Amazon issue that happened some months back, there were people that weren't affected by that simply because they designed their cloud infrastructure, or their cloud their apps in the cloud. They designed them for high availability, meaning if one site went down, they had another instance spin up somewhere, or they already had that instance running, and all they had to do was fail over to it. And so it's not solely on the provider, I don't think. I think it's a combination of the provider and the customer. But the customer has to be educated. They have to know and be educated by the provider as to, best practices as far as, like, hey, if you want your app to be up all the time, we have multiple geographical sites. It's best if you have another, a disaster recovery site somewhere else.
Exactly. And you know what? I was going to say, yep, Amazon has multiple different availability zones where you can spin up different instances. And to your point, yes, it's up to your customers to design that. You can have multiple cloud providers and be able to fail over. But from my experience with even a lot of companies with their physical infrastructure, they still trying to get a DR site up and running. And they still don't have a functional DR site up and running. And a lot to do with that is the budget. Upper management, they may say, we need DR, we need DR, we need DR. You say, okay, we're going to spend some time and focus on it. Then you submit the bill how much a true DR site is going to cost. So you're like, whoa, can we scale back some? So then you're dealing with that. So there's so many different factors on why people don't have that type of infrastructure set up at first until a real issue happens. Then once that issue happens, guess what? The upper management and stuff is going to say, how can we avoid this in the future? Well, you remember I told you it's going to cost X, Y, Z? It's like, okay, we need that. Go ahead and do it now.
Yeah.
So sometimes it takes you getting burned in order for progress to move forward.
Yeah.
And then to your point again, your staff have to be educated on how to implement such an infrastructure as well.
Definitely. Let's take it back a little bit. Let's talk about what makes up cloud computing from an actual infrastructure standpoint. Because both of us, we work with cloud computing. You worked on it from an app deployment side and from an infrastructure side. I myself has worked on it more from an infrastructure side. So some of the components, of course, that makes up a cloud computing. And this is business cloud computing. This is infrastructure as a service that we're talking about right now. A lot of people, they see the results of cloud computing or what they perceive to be cloud computing. Everything nowadays, people consider as a cloud. But and some of it rightfully so. When you throw your music up in Google Music, you're putting it up in a cloud. But what's behind that? What's driving that to allow you to be able to do that? And Google's private infrastructure, their cloud infrastructure on that side is pretty much what's driving that. So a lot of people see that and they don't see the behind-the-scenes stuff. So we're just going to give you a run-through on what makes up this cloud computing environment. So we're going to start off with, of course, one of the primary, everything is pretty much primary, but the compute resources. Now, I think Google does this totally different. They, the way, I've read a book, called In the Plex. If you want to go check out a good book about Google and learn how they do things and why they do things, go check out In the Plex by Stephen Levy. But Google, they use commodity hardware, and I'm talking about, regular, servers, nothing fancy with the servers, real low-cost hard drives, but they use thousands and thousands and thousands of them. Whereas a company where I worked at, we use, these super huge, beefy servers that have, a couple of sockets, 24 cores, hundreds of gigs of RAM for their compute resources. Now, compute resources is very important because that's what actually gives the virtual machines their resources. It gets segmented, so to speak, so that each virtual machine, you offer a virtual machine with a certain size instance. So you might have a virtual machine with 2 CPUs and, say, 4 gigs of RAM, and it gets taken out of that pool of resources. What makes it click together or stick together as far as a pool of resources is the virtualization layer, right? That's called the hypervisor. So you want to talk a little bit about about the hypervisors and, the different flavors of hypervisors that they have out there?
Yeah, we have the VMware hypervisor, then we have the Citrix Zen Server hypervisor, and I would say those are like the two main enterprise hypervisors that you will find in a company. Then you have several other ones out there that people mostly play with within their own home labs and stuff. But to focus on those two, I would say VMware definitely on the server side have a strong presence in the enterprise, and Zen Server is making strides, especially with their cloud stack infrastructure as a service application that a lot of hosting providers can use.
Yeah.
But I want to go back on the topic that you were talking about, infrastructure as a service, because when most people start to look at what cloud provider to go with, they're going to go with the simple thing is, what is that company's reputation, how many clients they have, all that. But to me, the key is the infrastructure behind their cloud computing. Because if I'm looking at two cloud providers and they both have similar pricing schemes, now how do I choose which one to go with? Because it's not apples to apples, because infrastructure is key. And sometimes you may not can get this information, like what type of SAN storage do they have, because that's going to affect your VM performance. What does the network backbone, how's that set up? What type of servers and computing powers, to your point, what are they using? All these different things is going to affect the performance of your virtual machine. So when I'm looking at two cloud providers and they both have similar pricing, I look at a 2 CPU server over here, 2 CPU server over here with 30 gigs of hard drive space, and all that looks fine. But when you actually start using that VM, are you really getting the best performance you can? Because once I/O starts to hit, there's many different factors that can affect the I/O of your the performance of your virtual machine, and that's going to affect your application in itself. So trying to find a cloud provider that's willing to reveal that information to you so you can really compare apples to apples on which company to go with and who's going to give you the best bang for your buck. Now, companies who have an open pocket, sometimes they don't care. They're just going to say, hey, let's just scale up and scale down when need be, right?
Yeah.
But to a lot of your smaller to medium-sized companies that do not have that open book, they need to be able to determine which company they're going to get the best bang for their buck. And having an experience, like you said, being able to work on the infrastructure side to see what all goes into building a public cloud or a private cloud, and you deciding on what storage to use, what network gear to use, cabling to use, servers to use, all that will affect the performance of VM. I remember earlier on when I got into virtualization, trying to tune virtual machines to run Java applications. Man, that was a pain,
Yeah.
Because some of the biggest things is the computing power today has made a lot of sloppy coders because they don't have to worry about cleaning up their code and best memory practice like the developers used to have to do back in the mainframe days. They had limited amount of memory, limited amount of CPU cycles. So they had to try to make the code tight as possible and more efficient as possible. But the physical server side of things, as we got more RAM, more CPU, developers, all they have to do is make sure it's functioning and working, right?
Yeah.
And we know that there's plenty of different ways of doing something in IT, but what's the best way? And I think virtualization is going to get developers thinking along that line again, because to me, a 2 CPU virtual machine would never compare to a 2 CPU physical server.
Yeah.
It can't. Just the way all the queuing and all that works, it won't. So you're going to have to go back on the developers, and you're going to have to fine-tune your virtual machines now to get that same performance. The biggest thing about cloud computing you get is that rapid, agile deployment. You can scale up and scale down as needed, and the cost is a lot cheaper.
Yeah. Yeah, I agree. And just talking about, you were talking about, disk I/O, and for people out there who are just getting into cloud computing and don't know what we're talking about when we say I/O, that's input-output. And that usually mainly pertains to storage. And speaking of, storage, that's another main part of cloud computing infrastructure. You have to have a good storage platform, or else, you're going to have poor performance on in your cloud computing environment. We talked about, some of the hypervisors. For those who don't know, like what a hypervisor does, it's a layer that sits in between your operating system and your hardware, and it abstracts the hardware so that these virtual machines, when you spin up a virtual machine, you can spin up multiple operating systems, virtual machines on one server, and it abstracts it and makes calls to the hardware, so that virtual machine thinks that it's the only virtual machine or the only machine on that hardware platform. That's the main reason for a hypervisor. And there's a few of them out there. You talked about Zen Server. You talked about VMware, who both of them are major players in today's virtualization game. Then there's a few others like KVM. Microsoft has Hyper-V. They have those also. So some of the components that their compute resources, which are these beefy servers that organizations will buy in order to offer compute resources, RAM, CPU, to virtual machines, or to people, so that they can spin up virtual machines. Then you have the hypervisor, which hypervisor you want to use, and all this does is pretty much abstract. It's a layer that sits in between that abstracts, the hardware that these virtual machines are running on. Then you get down to the storage platform, and these storage platforms are usually pretty immense. We're using NetApp. There's also other vendors out there, EMC, a lot of other storage platforms out there that people use. These SANs that are huge disk arrays that operate and give you some pretty fast I/O, and this I/O is needed when you're running these virtual machines, because these virtual machines, in order to get maximum performance, you got to have maximum I/O coming out of these, especially when you start deploying these high intensive apps out of the cloud environment.
Database servers, all that. When you start putting that on the VM, it doesn't equal your same physical machine. So now it's going back on the engineers and admins to do their due diligence on best practices and performance tweaks that they can do at the system level. Then once you exhausted that, now you have to talk to the developers again to make sure that they're doing all they can to write better code. And virtualization is definitely changing the game for the best, to me, on how apps are going to be developed and how admins are going to manage their environments. Yeah,
definitely. And then the other piece of this is, your network backbone. Are you running this over 1 gig, or or do you have are you running this over some of the latest and greatest, which seems to be 10 gig, or what's the network infrastructure look like for your cloud computing environment? That's huge too.
Yeah, how's the host servers connecting to the backbone, right? Like you said, Are we doing fiber? Are we doing a SAN? Are we doing a NAS? All that is going to affect the performance of your VM. Do I have a fiber channel going directly to my NAS appliance? Or am I using NFS over network or iSCSI over network? All that stuff is going to affect the performance of that VM. And when you get that call, hey, my app is running slow, and you can't give them a simple answer like, well, I'm looking at it. We gave you 10 gigs of memory. You got 4 CPUs. It's not our issue. Is it really your issue? How do you collect those metrics? How do you know that on the VM side and your infrastructure side, they're getting the best bang for their buck?
Yeah. So these are, the components that pretty much go into cloud computing. Now, these enterprises that are these ISPs, service providers that are offering this, have tons of this stuff. Multiple clusters of compute resources, and they have multiple disk shelves for their storage platform. Hopefully, they are using 10 gig, and hopefully they're connecting to their SAN using fiber channel. So this is the stuff that people don't see. These huge compute resources and servers and racks full of servers and things like that. Now, Google uses kind of a different approach. If you read that book in the Plex, you'll see the approach that they actually use for their infrastructure. It's pretty interesting, and their thought process behind why they built it like that is just pretty interesting too. Let's talk about some of the apps and the tools that you use day to day in order to build automation tools behind cloud computing.
Okay. I've been doing a lot with Puppet, which I've used Puppet in the past to manage our physical infrastructure. Manage. Puppet is what Puppet is. Okay. Puppet is a configuration management platform that you can easily use to manage your physical infrastructure, mainly used for servers. There's also tools out there like CF Engine that does the same thing, and a newer one is called Chef. Puppet is based on the Ruby language, but they also have a nice DSL, their little own scripting language, which you really don't have to know Ruby to do it. Chef, you have to rely on understanding Ruby a little bit more to create your config files. But Ruby and Ruby on Rails and stuff is not too difficult compared to some of the other scripting language out there. That's to me what I've seen.
When you say configuration manager, what is, because I know what that means, but for people who are just like getting into the cloud right now and thinking about possibly putting apps out in the cloud, or thinking about looking into infrastructure as a service, what do you mean by configuration manager?
Okay, I think the easiest way to explain it is typically when you build a server, you have several different steps that you go through, from what packages you're going to install, are you going to run the updates on the servers, Are you going to configure your host files? What users you're going to put on the server? Do you need to install Apache? Do you need to install MySQL? All these different little tasks used to make it difficult for admins to do and make sure that it's a repeatable process across the board. Now, when you introduce a configuration management system, you build the automation where it auto-builds that server. So you as an admin or engineer do not have to think about that anymore. You know, you may go through the process once to see exactly what you need to do, but then you use Puppet or CF Engine or Chef to automate it the next time you have to build servers. A lot of people remember that when you used to do the whole sysprep and stuff with Microsoft, right?
Yeah.
When you deploy images and stuff to desktops. But on the server side, we use these automations to actually automate a server. So I don't have to think about it anymore. I know that the next server is going to be built exactly the way I need it to be built because I'm taking a human error out of place. Because I've seen so many times when you don't have configuration management systems, people get lazy. They forget to do something, right? You're not trying to go down this long checklist of everything that you have to do. Your company have all these different policies and procedures that you need to follow, and you need to make sure you're crossing your T's and dotting your I's. A lot of steps get missed because everyone's in a rush nowadays. We need that server now. So you're doing the bare minimum to get it up and running to hand it over. So automation... Yep, automation makes it easy. You know, you build your templates and your profiles, and you let that handle it, and it's beautiful. You don't even have to think about it. Now, when you automate, you may make some people lose their jobs because we don't need as many people, but it makes your job easier because you can kind of focus on more things that's more complex and more challenging. That's why I like it. You know, I'm going to automate this, but now I can focus my energy and my time on things on troubleshooting or how can I improve the company services. And that's what you got to think about, too. Be the guy who knows how to automate their infrastructure, but also be the guy who knows how to do the research on how to make the process better.
Now,
right?
Now, when you're using Puppet or one of these CMSs, these configuration management systems, and you build out a template, right? And this template contains certain packages, okay? So now you've got a system that you're going to deploy that has, you know, a certain version of Apache or a certain version of PHP. Now, how easy or how simple is it, or do you end up having to build an entirely new template? Would it be for you to, say, switch out a package or update a certain version of a package?
Okay. I'm going to talk from the Linux side of things when you're managing like a CentOS or Red Hat or SUSE. And to answer that question is going to really be how easy it is or what package management system you use, right? So if you're going with anything that's in your different repositories that's provided by the vendor you choose, or are you custom building your packages? So if I'm going with all Red Hat servers, then I'm going with their repository. It's really simple, you know, because I'm going to say install packages from this repository and run the update command, right? So that's simple. It's easy to tell a configuration management system to make sure that this package is installed and it's at its latest version. Okay, in a production environment, that's not realistic. You're not going to just have it automatically update because you want some testing, right?
Yeah.
But once testing is involved, testing has taken place and you verify that the update won't break anything, or if it will break something, you know how to go about fixing it, then you can move the automation into place for the other environments. So it's fairly easy to switch out packages and stuff, but some things it may take some time. Like, I'll give you, for example, one of my packages, I'm actually having it automating, doing a wget. It gets the package from the internet site, downloads it, unzips it, change directories, and I supply it with my compile commands. It compiles it, builds it all in a matter of seconds, automated. And that package, upon me compiling, depends on other different pieces. So within your configuration management system, you can sit there and say, before doing this step requires this. Well, after this step is done, notify this, whether it's a service, whether it's another package, whether it's a file, all that. You have complete control over your steps. So it does take a little bit of time to test to make sure you have everything happening in the right steps.
Yeah, but the time you'll save
in the long
from
run,
building systems in the long run makes it definitely worth it.
Oh yeah, because the next time I have to blow out, say for instance, I have to completely blow away a whole environment, it's going to take me 5 minutes to build the new environment. I mean, it's so beautiful when you put that automation in place. When you have automation and backups, go ahead. Sorry.
No, go ahead. Finish that because I have a question. Well, when you're done.
No, I was just saying it's so beautiful when you have automation in place because you don't have to think about it. You know, if you don't have the proper backups or anything, or if a developer or they say, hey, we want to blow this away, redo it, you know, you just spin up the servers and let the automation take place. And there's ways to define if a server is going to be a database server, an app server, load balancing server, caching server, whatever type of server you need it to be. And some of the challenges that I've seen in the cloud versus the physical environment, like in Puppet, you're able to define a node by their DNS name or IP or whatever. When it comes up, it checks into the Puppet master. Hey, if this DNS name is this, build it this way. If it has this IP, build it that way. But with the cloud, when everything is so elastic, so dynamic, and things change, and one thing in the Amazon cloud, every time you reboot that server, it gets a new DNS name and IP address. So some of the you have to account for that. How do you automate that? Yeah. So that was some of the challenges that I had to come up with figuring out how can I distinctively figure out what type of server this is going to be. And one of the things I used was within the cloud, you can define security groups, just like you do pretty much like you do your own network, right? When you're building out an infrastructure, you say, okay, I have my database servers that's going to be behind my database network and subnet. I have my app layer that's going to be in my app layer network. And I have my web layer that's going to be in my web layer network, right? So based upon those security groups, all I'm doing is saying if this instance is part of this security group, build it out this way. Because what I failed to mention was within Puppet, they use this other app called Factor, which I baked into my AMI. And Factor gathers a bunch of different information about that instance, like what security group it's part of, what their DNS names, and a bunch of different stuff. What type of instance it is, meaning the size. Is it a micro? Is it large? Is it extra large? Whatever. So now I'm able to build my automation script saying if it's part of this script and if it's this type, build it this way.
Gotcha.
And it took me a little while to say, man, how am I going to figure this out? Because trying to get to know the cloud and what all the different features of the Amazon cloud or any of these cloud providers, even though, you know, you and I have experience with building a public cloud infrastructure, but trying to wrap that around on how do people use the cloud infrastructure? How do they want to use it? Because traditionally a lot of people are going to try to build it out the way they know how to build it out. And honestly, they need to look at, can I do it differently or better? This is a new technology.
Gotcha. Yeah. I wanted to ask you about deploying or using these tools like Puppet and Chef and to deploy stuff to the public cloud. How does like a company like Amazon aid in that aspect? As far as, do they offer an API that allows you to hook into their infrastructure?
Yeah, so Amazon and even your CloudStack and OpenStack, all of them have their own different APIs, and a lot of them interchange. Like I know the CloudStack have a product called Cloud Bridge, where if you start building out scripts to work in Amazon Cloud, you can use those same scripts to talk to the CloudStack if you put Cloud Bridge in place. Then there's something called Delta Cloud, which is made by the Apache and Friends groups, where their whole concept is forget about everyone's APIs. You just drop this server into the cloud, and you make calls to your own API and be able to deploy and let that manage everything, right? So there's different ways to skin this cat when it's talking to your cloud, and they most likely all of them have an API. They all have different tool sets for Python. I know for EC2 Python, you use this module called Boto, B-O-T-O, which is really nice. I mean, it's really nice. It has a nice little framework or module you install into Python, and you can, once you have your key and your secret key to talk to your Amazon API, you use this framework to sit there. You can spin up instances, you can shut down instances, you can list out all your instances. You can do a lot of different things. And Perl has something similar, Ruby has something similar, and they have all these different tools for you to manage your cloud environment. Because if you're like me, I'm not trying to be in a GUI all day. I cannot stand being in a GUI. I want to script it. I want to be on a command line because that's where I'm quick at. And that's the key, is being quick and agile. You don't have time to sit there and click, and try to figure out all these screens. Just tell me what I can talk to and let me script it out and get it done with.
Gotcha.
So to answer your question, yes, there's many different APIs with all these different cloud providers that you can write your own tools to manage it. Then you have companies like RightScale that's coming up, where RightScale is another GUI-based product that you can talk to multiple different clouds from one console. So if you have, say for instance, you do have your public cloud environment with Amazon, but then you decided to build your own private cloud in-house with VMware or CloudStack or OpenStack, you can use RightScale. Yep.
To manage both environments from one. That's pretty slick. That's pretty slick. Now, for the majority of this podcast, we've been talking about infrastructure as a service. There are other as a service cloud types out there. There's software as a service, and there's platform as a service, where software as a service is more like say like Google Music or Google Mail, or even providers that offer like hosted exchange. I would say more like stuff like hosted exchange, where you are more in control, or you can give these businesses more control over their the actual resources. As far as the ability to be able to increase and decrease their resources on demand. Now, that to me, that's key, simply because if not, then you're just using a web service. To me, like for instance, like Google Music, which is pretty cool, but they give you a set amount of space, right? And once you hit that limit, that's pretty much it. Whereas you have something like, software as a service such as, say, Hosted Exchange. If you need more space or need more storage for your mailbox, you can increase it. If you are suddenly, for some reason, you bring on another or you acquire another company, it's easy for you to, add more users. And they have the infrastructure in place behind the scenes that will accommodate, this extra company that you just acquired. Google Music is considered software as a service as well, but I would consider it as much as something that you give the user more control to be able to, scale on demand.
Yeah. So to me, software as a service, from a business standpoint, like you mentioned, where you have your now hosted exchange service, or there's your Salesforce.com or SugarCRM.com, all these different tool sets that a business would use, or even your regular user would use, where you don't have to worry about supporting or building the app yourself. Where now I don't have to have a team of exchange experts or CRM experts, or whatever the app may be. I don't have to have a team of experts in-house. And to me, it's a win-win situation, because for the vendor itself who's offering that service, they don't have to sit there and think about all the different type of environments and setups to support, because everything is on their infrastructure. They building their infrastructure to the best practice of their app. So when you go to a software as a service, you're going to get the top of the line usage out of that application, because no one knows their application better than them. So they're going to have all the best performance tweaks for that app. And again, you don't have to have the team of experts. So you're going to save time and money just by going with software as a service with specific apps. Now, every app probably should not be software as a service. You should host your own internal apps, and that's just depending on, again, there's so many different scenarios where it comes into factor on choosing what should be software as a service and what should not. Then we talk about platform as a service, which now is particularly like, okay, we have a lot of in-house custom apps, whether I'm just going to use the two examples that I'm really familiar with, is your LAMP stack, which is your Linux, Apache, MySQL, PHP, or even LambJ with a Java thrown in there, or even an Oracle backend, where I'm going to provide you a platform, not the app, but the platform, where I'm going to build out a good version of Apache tuned, MySQL tuned, or Oracle tuned, PHP tuned, or Java tuned. So I'm going to provide you a nice platform that's tuned, and all you as a developer have to do is worry about deploying your application into that stack. So all you have to do is deploy your database schema in your application. If it's PHP, you drop your files in. If it's Java, if you have a WAR or EAR file, you do a deployment that way, you deploy it. So that's more of your platform as a service, and that's still an up-and-coming market to me. There's a few companies out there like CumuLogic, CUMULOGIC. I think they have a very nice product right now for your Java-based platform as a service, where you can go with their hosted service, or you can take their platform and build it in your own in-house and use that. And they support Tomcat, WebLogic, and WebSphere and all that, with even a MS SQL backend or a Oracle backend or MySQL backend right now. So, again, if you're doing software as a service, I think is good for a lot of different apps. Platform as a service is going to be good. And even for your own in-house, if you have your own private cloud, your engineers pretty much should be developing your own platform as a service. That's the new admins. We don't admin servers anymore. We build platforms where it's easy to deploy these applications, where no one's thinking about the server administration, because all that work, like I said, with the automation and everything, all that is tuned and in place. All we care about is getting your app into that platform and making sure that it works, and talking with the developers if it doesn't work. Either we recommending best practices to them, or they telling us how we need to change our stuff to fit a new model.
Yeah, and companies, I see a lot of, cloud provider companies actually offering, some type of platform as a service, simply because when it comes to the cloud, some of the most the people that it's going to attract the most seems to be, these a lot of these startups, people who want to, who develop an application and want to deploy it. And all they really want to do is deploy it. They don't want to have to worry about, spinning up a server and worrying about patching it and worrying about, anything. All they want to do is deploy their app, and if their application is getting hit, it's scaling up. When it's not in use, it's scaling down. And that's all they really want to worry about. They don't want to have to worry about server administration. So platform as a service gives them that ability. All they have to do then is, like you said, deploy their app to the cloud and let automation tools worry about scaling up or down.
Yep. So with that said, you touch on a couple good points. One, a lot of admins are thinking, where do I fit in this process if a developer can just go deploy their app without me? So to me, it's not going to be that simple to replace the admin as it's felt. Well, if all you're thinking about is administrating the server, yes, your job is in jeopardy, just like how PC Tech jobs were in jeopardy. So if you're an admin, you need to be thinking along as an engineer mindset, is understanding the whole stack and being able to put all the pieces together, meaning understand how the back end works, the database works on best performance tweaks, understand how the app layer works on best performance tweaks, and the web layer works on best performance tweaks. And you can engineer a whole application through that whole cycle, because every app is not built the same, because you have different levels of developers again, right? So your goal is to move that app through this whole cycle, best practices, because what you get caught up in, I see so many times, is engineers trying to tell developers how to code, and developers are trying to tell engineers how to set up their servers. So you have to just understand that whole cycle on how to be able to make the best decisions and really prove your point across. And then you need to be able to build these environments. And you also have to be willing to learn how to do new things, because there's new concepts, new ways of doing things coming out all the time. And you can't say, well, this was the best way of doing it. You have to do your research. You have to stay on top of your game. You have to go to these conferences, because there's techniques coming out all the time. And you don't want to be set in your ways where you get left behind and you be the bottleneck in deploying an application or meeting deadlines. So if you want to keep your job is to stay on top of technology and be able to provide the best platform that meets the business needs. You have to be able to convince your team and everybody else the reason why this is the best platform. And you have a lot of hurdles. You got to convince the security people. You have to convince the business people. You have to convince your manager. You have to convince the developers. And, so if you want to keep your job nowadays in this market and where we're moving, you have to be well-versed in all these different areas and be able to build that whole stack. Engineers, to me, are the new architects.
Yeah, and that's a really good point as far as when it comes to jobs and careers, especially nowadays. Now that a lot of companies are finding out more and learning more about virtualization, even just from an infrastructure side of it, you kind of have to know a little bit about everything, right? So you have to know about networking, and then you have to know about storage area networks or SANs, and so then you kind of have to know about file systems and the different type of performance tweaks that you can do in order to, in order for your cloud to operate at peak performance. And then you have to know about virtualization as well. And then when you get more into the application side of it and deploying apps, then there's a whole another can of worms that to be open with that, as far as knowing the entire, like you said, knowing the entire stack, on the application level. So when people are out there and they're talking about, I see a lot of threads about, getting into IT, or, what's this going to mean for, these server administrators and things like that. IT is changing all the time. It constantly changes. This is just something that you have to adjust to, right? You just have to embrace this new technology, called cloud computing, virtualization. And people say, I just want to touch on this again, because people say virtualization has been around for a long time, which it has been. Virtualization has been, mainframe computers and things like that, which allow multiple people to access it at the same time. That's a form of virtualization. But this cloud computing thing, to me, is something that is new. Never before have I seen a time where you can, scale up dynamically, being charged, per, for compute resources being used in a metered type of way. And this just adds another thing into as far as careers are concerned, because now, the new administrators and the new engineers, they have to know about this entire platform, this entire stack, from, physical infrastructure aspect of it all the way up to the application aspect of it.
Yeah, you as I like to call them engineers/app integrators, because it's our job to be able to talk with everybody that the application touches. So you have to know networking. You have to know databases. You have to know systems.
Yeah.
You have to know applications, because everybody else is going to be pointing their fingers at each other on why the app isn't working. You need to be able to quiet out all that noise and be able to pinpoint what the real issue is. You need to be able to know what tools to use to crack open and sit there and say, okay, you know what, the request came in really quick. It moved from the web server to the app server, and it went from the app server to the DB server. It took 30 seconds for the DB server to respond. Okay, what caused the DB server to respond that slow? Was it something on the network side? Was it something on the network, on the DB side? I mean, there's so many different factors we can go into. What made that request go slow? Was it the query? You know, a different request came in, different type of query. It responded fine. It could have been the query that was slow. Just so many different factors I can go into what can make an application slow. But it's up to us as engineers. Then we start looking at the database. Is there different database tuning we can do? You know?
Let's do this. And I don't mean to cut you off, but what I want to do is I want to continue this cloud talk because you're bringing up a lot of good points, and that can be a whole entire another segment on cloud computing when we discuss, like, you know, fine-tuning things for the cloud and troubleshooting applications on the cloud. And I want to actually bring Wavell into the discussion too. And Wavell is a developer, and he's well versed in, you know, deploying things out into the cloud as well. And I think that would make for a real good discussion for, let's say, part 2 of this cloud discussion.
Oh yeah, I agree. That's a whole another podcast, 2-3 podcasts, and I think it's going to be more than just cloud computing. Like you said, it's the whole process, because we're talking about cloud, but then if you want to talk about application troubleshooting, network troubleshooting, all that, I think that would be a good conversation for the listeners and viewers and people who's trying to figure out where do they fit in IT and where do they want to go in IT, and how they can keep their jobs in IT and stay on top of the game.
Definitely. I mean, that's what this whole platform is about. And, you know, Blacks in Technology is informing our peers out there in the community coming up or who want to come up in technology, and giving them some insight, you know, from some experienced people, and giving them some insight as to, you know, what these technologies have to offer, what it can offer you, and what things you can do to get better. It's all about knowledge sharing, and that's what we're doing here tonight. And you know, for our next few episodes, man, we can just continue this. We can talk about you know, deploying apps in the cloud and troubleshooting apps, and then we can get into troubleshooting networks. I mean, there's tons of stuff that we can talk about that spins off of this whole cloud talk. So let's save that. Let's bring Wavell on for our next podcast, and we can get, you know, even deeper into this discussion about that.
Yep, sounds good, man. Good discussion, and I look forward to the next podcast with Wavell, and let's keep it going.
Yeah, definitely. Thanks, everybody, for tuning in. That's the Blacks in Technology podcast for this evening, and we'll see you next time.
Bye.
Blacks in Technology.
Blacks in Technology. Blacks in Technology. Blacks in Technology. Blacks in Technology. Blacks in Technology.